In this video, we're going to have a look at how to use the formula sheet in 3D vectors questions in the A-level further math syllabus. So this is a snapshot from the OCR formula sheet. All the other ones are quite similar, but notice all the information you're given. And in a vectors question, I think the first thing you should do is turn to the relevant page in the formula sheet, because there's so many formulae given that mean you can actually get away with answering a question without necessarily fully understanding the content. So I'll give you a few examples from a few different exam boards here. So this is all the information given. And let's take an example from the OCR exam board. And this one's from the OCR Further Maths A specimen paper. So it says the lines L1 and L2 have equations, well, there they are there. Find the shortest distance between L1 and L2. Well, instantly that's quite a difficult question, so let's have a look at the formula sheet to see if there's something that tells us the shortest distance between two lines. So actually we're given it here. The distance between skew lines is D equals that, where A and B are position vectors of points on each line, and N is the mutual perpendicular to both lines. So we're going to have a look at how to tackle this question using that formula there. So what's also going to help is to get these two Cartesian equations in a vector format. Well, actually, we can see in the formula sheet as well, there's something that's going to help us with that. The Cartesian equation, which we've looked at in another video on how to get it between Cartesian and vector format, is actually given here. So this Cartesian equation here can be written in this form here, where A is the point on the line and U is the direction. So this is just telling us that this Cartesian equation gives the line R equals a point on the line A1, A2, A3. That's this bit here, plus lambda, this bit here, U1, U2, U3. So we've got how to get between Cartesian and vector equations. So let's do that now. So using that formula sheet there, we can see that in part one, this vector equation has this Cartesian equation has the vector form R equals 3, 5 minus 2 plus lambda 1, 2 minus 3. And this one here has equation R equals 4 minus 2, 7 plus, and we'll use a different letter to lambda, let's use mu, 2 minus 1, 4. So we've got in a more helpful format. So now it says what we need here is we need a normal, a mutual perpendicular to both lines, and 2 points on each line. Well, we've got 2 points on each line. That's a point there, and that's a point there. So all we need to do now is find the normal. Well, we can do that by finding this the vector product of these two vectors here. It'll give a mutual perpendicular to both lines if we cross product their directions. So N equals 1, 2 minus 3 cross 2 minus 1, 4 equals, so let's cover up the top row and find the determinant of the remaining entries. So the determinant of the remaining 2 by 2 matrix is 2 times 4 minus 3, so 8 minus 3, which is 5. Then move that down, cover up the middle entry. But remember, the middle entry is always made negative, the sign of it's always changed. So negative, so 1 times 4 minus minus 3 times 2 gives minus, and the answer to that was 10, so negative 10. And then again, let's move down, let's cover up the bottom and find the determinant. This time we don't change the sign back to being positive again. So 1 times minus 1 times take 2 times 2, so that makes minus 5. Okay, so we've got that. So now we're ready just to shove these values in the formula. So just to remind us of what the formula is, there it is there. So what we need to do is to find B minus A. So B minus A equals, and that's the 2 points subtracted from each other, so B minus A, showing full working, makes us more likely to get marks in the event of a wrong answer. 4 minus 3, minus 2 minus 5, and 7 minus minus 2, which is equal to 1 minus 7. 7 minus minus 2 is 9. So we've got B minus A there. Now we need to dot that with N. So B minus A dot N equals 1 minus 7, 9, dot 5 minus 10 minus 5 equals, so scalar product, so the answer is scalar, equals 1 times 5 plus minus 7 times minus 10 plus 9 times minus 5 equals 30. And the numerator was finding the modulus of that, so if I go back and modify my answer, so we needed the modulus of that, which becomes the modulus of that, which becomes the modulus of that, which is still equal to 30. So then we need to find the modulus of the normal. So the modulus of the normal, going back, what was the normal? The normal was 5 minus 10 minus 5. So the modulus, so I should really write modulus of n, make the examiner know exactly what we're writing, what we're finding out. So the modulus of 5 minus 10 minus 5, just check that that was right, yeah, 5 minus 10 minus 5 equals the square root of 5 squared plus 10 squared plus 5 squared equals root 150. Therefore, we're ready to just calculate it. So 30 divided by root 150 is equal to root 6. So that implies that the distance equals 30 over root 150 equals root 6. So let's remind ourselves of part 2 of the question now. It said find a Cartesian equation of the plane which contains L1 and is parallel to L2. Well, we've got vector equations of each line now. We've got them here. So let's just copy and paste those. That's that there. So this first one is L1 and this second one is L2. So it's got to contain this line here and be parallel to this line here. So we'll have a look back up here. We see that the Cartesian equation of a plane is that there, where this is the normal vector. Now you should know that, you should remember it. However, if you don't remember it, it is here in the formula book. So, to get the normal of these two, we need to find the cross product of the two. Well, luckily, we've done that already. Here it is here. So we've instantly got something we can sub into the formula. Let's make that look more like a 3. There we go. So we can sub that into the formula. So 5x minus 10y minus 5z plus d equals 0. Now we sub in a point. Well, actually, if this line lies on the plane, then this point must be on the plane as well. 3, 5 minus 2 must be on the plane. So if we sub that in, so let x, y, z equal 3, 5 minus 2. Well, this implies that 5 lots of 3 minus 10 lots of 5 minus 5 lots of minus 2 plus d equals 0. Therefore, what we have is d minus 25 equals 0, which means that d equals 25. Therefore, the Cartesian equation of the plane, 5x minus 10y minus 5z plus 25 equals 0. And what we could do if we want to simplify it a little bit, arguably simplifying, I suppose might not really be simplifying, but all of these are divisible by 5, so we can divide both sides by 5. I'm not going to bother, but you can if you want. It's an equivalent, simpler, arguably, simpler form. So, but that answer as it is perfectly acceptable. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.